Hello there, everybody. Hope you're doing well today. This is the second lesson of Unit 4 of quadratics, and today we're going to be looking at quadratic graphs, so the parabola shape that we just saw last lesson. There's going to be certain points on these graphs that you need to know the terms for and then how to label them. First, though, before we start, I just wanted to give you a summary. I'm going to put this into full screen now. A summary of how to tell the difference between linear and quadratic equations or graphs or table of values. So, and we're going to go through this for the rest of the unit, and you will see this as you go into grade 11 and beyond. So it is a really good thing to know how to do to tell the difference between linear and quadratic in various ways. So if something is linear, the equation follows the form y equals mx plus b. So there's always going to be a number before the x, and sometimes it can be 1. So there could be an x by itself and then adding another number that's by itself. When you look at the table of values, the first differences are going to be the same for linear functions. And if you graph them, well, it's going to be straight line like it is here. For quadratics, instead of just having an x, there's going to be an x squared term in it. So that's a really good clue to tell you that an equation is in quadratic form. There can be other numbers here, and we're going to get into that, but you'll want to look for this squared term. For a table of values, the second differences are the same. So you do the first differences and then you do the differences again, and you'll see those will be the same if it's quadratic. And for a graph, it's going to be this U shape, or as we saw yesterday, it might just be half of the shape depending on how much you graph. Okay, so that's just a quick overview. We'll go through this a number of times, but this is a really, really good table to maybe copy down, maybe pause it here, copy it down. You can go into the slides yourself and make a copy for yourself in your own Google Drive. It's really good to have on hand as we go forward in this unit. Okay, so let's talk about the quadratic graph, so those parabolas. So what we're going to do is we're going to look at the shape of these, and we're going to be able to identify key features. So I'm going to introduce some new vocabulary here. I'm going to give you the definitions, and then we're going to do a couple examples how to find those features. Some of the terms you will be familiar with. So these are the terms you need to know when we're talking about parabolas, or quadratic graphs. So the first one is the vertex, and the vertex is the point that's at the very bottom of a graph, or if it's going the other way, the very top. And I'm going to write in the definition in a bit here. The maximum or minimum value, you can imagine this is a minimum, right? It's the lowest value, and it's going to be your y value where it's the lowest or the highest. The axis of symmetry is, you can imagine if I draw a straight vertical line, a straight vertical line to split the parabola exactly in half, you can see that it's symmetrical. It looks the same on this side as it does on this side. It's like as if you put a mirror along this axis, this line here, to make it look exactly the same on both sides. So that is called the axis of symmetry, and it goes directly through the vertex. So that's actually going to be your X point of your vertex. Your y-intercept, you've seen that before. It's where it goes through the y-axis. And your x-intercept, or intercepts, is where the parabola either touches or goes right through the x-axis. And then zeros, that just means the same thing as your x-intercept. That's just another name for x-intercept, is when is y 0, and then you pick out the x's. So this is those terms, those new terms for you labeled on the graph. So what we're going to do, I'm going to go ahead, go to the next slide. Oops, wrong slide. So I'm going to go here and I'm going to exit out of this screen and we're going to write down the definitions here, and then you can always go back to see them. So the definition of the vertex is the highest or lowest point of the graph. It's also where, if you notice, it's where the curve kind of starts to change direction, because notice this is going down and then it changes to up. So where the graph changes direction. Move this up a bit. So how you label it? Well, it's a point. So you have to label it with the x coordinate first and then the y coordinate. Okay. Now for our graph A here, our x value is 1, 2, 3, 4. So it's going to be 4. And our y value, well, it's right on the x-axis, so our y value is 0 in this case. The maximum or minimum value, this is the y value of the vertex. So all you do is you just pick out your y value from your vertex, and you're going to write it in the form y equals something. So what y equals whatever that point is. So in this case, our y value of the vertex is y equals to 0. So that is, it's a minimum this time, right? Because it's the lowest. Okay. Axis of symmetry. This is the x value of the vertex. And I know this is quite new for a lot of you. So it'll take some practice to get used to these terms. But that's okay. This is what happens every time we learn something new, right? So don't get too frustrated with yourself if you don't understand right away. It will take some practice and you will get to it. You will see this again in grade 11 and you will go over again. So don't worry too much about it if you're not getting it right away. Okay, so the x value of the vertex, our x value of our vertex was 4. So that means our axis of symmetry is x equals 4. Our y-intercept, well, you know this, where your graph goes through y-axis. And so here, this is 1, 2, 3. So it's between 3 and 4. Let's just say 3.5. And it's just going to be a number. So it's just going to be y value. Or it could be 0 and y, right? Because it's a point. So 0 and our y value, what did I say? 3.5 in this case. X-intercept, well, that's where the graph touches x-axis. I go read this up. And those are going to be in the form x comma 0, because remember, y value along the x-axis is 0. Now this touches the x-axis at the vertex. So 1, 2, 3, 4. So it's going to be 4 and 0. Okay. Zeros are the same as x-intercepts. Intercepts. So that's again going to be in the form x comma 0. Now you can imagine if I move this parabola down, it's going to go through the x-axis twice. So you might have 2 x-intercepts. Or if I move it up, it might not go through the x-axis at all. So you might have 0. So just know that you could have 1, 2, or 0 x-intercepts. So in this case, it's going to be the exact same as above. Okay, so I'm just going to present that so you can see it in a bigger screen. Okay, there's everything for this graph A. So I'm going to do another graph just so we can practice it one more time. And then you guys are going to practice it with the graphs that we did yesterday. Oh, we didn't do the graphs, but we did. Well, no, you did the graphs, so never mind. Okay, so let's take a look. The vertex, remember, is either the bottom or the very top. So this one, it's going this way. So you're looking at the top now. So 1, 2, 3 and a bit. So 3.5 is the x value. Remember, because you have to do x first and then your y. Then 1, 2, 3, 4, 5, 6. So our point is 3.5 and 6. Okay, remember your maximum or minimum value is just the y value of your vertex. So y equals 6. Axis of symmetry is just your x value of your vertex. So y equals 3.5. Y-intercept. So it looks like it goes through the y-axis at about 2. So we'll put in 0, 2. Now see the x-intercepts here. See how it goes through the x-axis at 2 points. So you're going to write down both of them. So the first one goes through the x-axis at -1, and then the y value is 0. And it goes through at 1, 2, 3, 4, 5, 6, 7, 8. So 8 and 0. And the zeros are going to be the same. Why is it called zeros? Well, it's called that because the y values are 0. Okay, so there are a couple examples for you. Oops, and I did that on the wrong, so I'm just going to move those. Okay, so let's present that just so we can see that again. There are the solutions for that. So what I want you to do, I've made up a practice set that's called 4.2 Features of Parabolas Practice, and I've included the the solutions at the end in a table. I've just done some graphs on Desmos and gave them to you with the equation as well. And then once you're done and you feel comfortable with that, you can do the 4.2 Features of Parabolas quiz on Brightspace. It'll basically, here's a parabola, tell me what the key features are, okay? If you do have any questions, please let me know. Using that envelope in the top right corner of Brightspace, you can instant message me or send me an email. All right, that's it for this lesson, guys. So I'll see you next time. Bye-bye.